Welcome viewers. Today we want to look at analysis of losses in prestressed concrete beam, and we are going to look also at cable profiling. Now we have a question on the board which we want to use as our guide. All right, so we have a question. Says figure Q2 shows a proposed cable profile of a 20.35 meter post-tension concrete bridge beam with 0.15 meter as anchorage recess at both ends. Now the question we have, in this question we have 5 control points which are being fixed. Now for the profiles, the part of the profile between the control points are 1 and 2, 4 and 5. They are the straight part of the profile. We have the other part which is parabolic in nature. We have control points 2 and 3 and 3 and 4 being parabolic in nature. Now the parabolic part is governed by the equation of a parabola, while the straight part of this profile is governed by the equation of a straight line, which is y is equal to mx plus k, where m represents the gradient and we have our k representing our intercept. Okay, we have the x and y coordinates of the profile. Okay, now we have been given this profile. Now the coordinates on the profile at various control points have been taken. Now for control point 1 and 2, 1, 2, 3, 4 and 5, we have the coordinates at 0.15, 0.15, 0.89, 1.175, 0.54, 10.175, and so on and so forth respectively. So these are the coordinates of the various points. Now the question we want to treat, number 1, is to obtain the constant values for the expression for the equation of a straight line. Of course, if we intend to carry out the profiling of these pre-stressed concrete, haven't done the profiling, we must check to know if our choosing profile is sufficient enough to be able to sustain the necessary losses that will be encountered in the concrete. Of course, we know that the losses that will be encountered include the losses due to shrinkage, losses due to elastic shortening of concrete, losses due to slippage of anchorage, losses due to friction, and so on and so forth. So all these losses need to be accounted for in the design. Now for us to take these losses, we need to first of all get the expression for the profile. All right, the expression for the profile is two basic expression, which one is a equation of a straight line, the other is a parabola between in between the beam. Okay, so once we are able to obtain the expression for the profile, we can obtain the slope at every point, and as well we can obtain the losses that will be encountered along the beam when during pre-stressing or during the service life of the structure. All right, so this is what we are going to do. So today we just want to obtain the expression for the profile before we start talking about the losses. And for us to do that, we must get the constant of the expression, which is a, b, c, and m and k. All right, we already know what x and y are in this problem. All right, so taking a look at the beam, we have we've been given the points from point 1 to 2. 1 to 2, we have the profile, the coordinates. This becomes our, here becomes our x-axis, here becomes our y-axis. So we are saying that from here, which is from control point 1 to point 2, we have that distance as our x, which is 1.175. So we have that. Also, we also know that from the point 2 down to point 3, we have the coordinate in the x direction to be 10.175. So it means that from here down we have 10 point. We have this one from here. down to this point. So we are saying from here down is 10.175. Okay, so I'm picking from this end 10.175. So approximately between point 2 and point 3 is about 9 meters. Okay, so the next point we have is these are the middle points. So we have the next one 3 to 4, point 3 to 4. We have that to be 19. So from 3 to 4 from here, which is from the ending here, we'll have that coordinate. So here is 19.175. Okay, so we will have it here. Okay, so we have 19.75. Then we have the next coordinate is 20, which is the last one. So we have 20.2. So if we measure from here to here, we can take up to 5, which is 20.2. So we'll take it from here, sorry, from here, from the recess part. Remember that we were told that we have a recess of 0.15 to accommodate our anchorage, okay? So what we are saying is, these are the S coordinates. Then the Y coordinates are the distance from edge point from the x-axis to the vertical, where we have the curve is plotted along the beam. Okay, so this is what we want to do. So we are just going to look for this constant and proceed further in obtaining the losses. Now take note that the primary purpose of profiling is to ensure that the cable profile choosing satisfy the requirement for ultimate tensile stress of our cable. Remember that the ultimate tensile stress for our cable, depending on the cable type, we can have cable that have their UTX to be around 80%. So such cables, you must ensure that the stress limit does not exceed that ultimate tensile stress. So once we are able to calculate the losses, we will find out all this. When the section is not adequate in terms of accommodating losses, we can do a review by resizing the section, changing the section, probably increasing this depth of the section as the case may be. All right, so thank you very much for watching. As we proceed into the next video, we'll be doing a calculation on cable profile. Thank you. Have a wonderful day.